welcome to my talk. It's a mouthful, I'll admit that. It's about diagrams, so it's not a very heavy talk, so I hope that it's okay to still absorb after all the incredible talks that we had today. So first of all, welcome and namaskara. I am originally from Kolkata, but I'm living in Amsterdam for the last 2 years, 2.5 years now, and that's how it's not a typo, they spell welcome with a K. And I hope I got the spelling right for namaskara. But professionally, I've been a software engineer for, 10 years now, and I'm currently working at booking.com. And over the last 5 years, I've been writing about topics that I feel have a foundational impact to us as an industry or a community. And if you search for my name, you might find a few. But getting into the meat of the topic today, it is something very foundational, I would say. And that starts with realizing that we, as an industry, decided to go from monoliths to microservices. We said that, these big balls are hard to manage, these really massive structures are hard to keep up with, and we said that we'll break it up into smaller pieces. We call them microservices, just like a puzzle, and these smaller pieces work together to give us emergent behavior. And we tied them together with the API, and that's what this conference is all about. And this system, microservices and the API, talking together to form one whole, has worked really well. They gave us a lot of benefits, and that's why all of us are here today. All of us are doing this. There are many talks about microservices today. But my talk is about something that impacts us while dealing with a lot of microservices, so the downside of microservices, and that is fragmentation. Because we have more pieces now, it's harder to see the bigger picture. Think of one piece of the puzzle. It's much harder to see what it will make if you just look at that one piece as one unit. But the product that we build usually is for the whole thing together. It's not just that one piece. So whatever we do, we have to make the product seem like a whole. And that poses two problems. One, it is fundamentally harder to change if you have more than one moving piece, and it is not very easy to understand because you can't see the whole thing at a time. So let's dig deeper into these two areas. The first problem is that a system that is built on fragments, like microservices, is hard to change. And that's primarily because these fragments that we have built, these microservices, compose in very fixed ways. So let me take an example. Say we are building a key value store, and we say that this key value store has get and set operations as APIs, and it can set a key against a value, and you can get the value from the key as an API. But then we want to improve this functionality. We want to provide more things to the user, say that we want to store not just the keys and the values, but also the historical values of a key. So we say that we build a microservice because it has its own concerns, it's its own API, it exists as its own. Whenever we get a new key or an update to a new or existing key, we say that call the history service updated. Then we say that, okay, that is good enough, but we now want to provide prefix searches, regex searches, and that is something that doesn't fit well into the key value store or the history service, so let's build a search index on top of it. And that is its own microservice, and that provides the search functionality. But then we said that, okay, we want to search in not just English, we want to search in Kannada, we want to search in Dutch, we want to search in, French. And then he said, okay, we can do the translations, and this can be its own microservice because it has its own concerns, it has its own other downstream APIs that it provides. And then we said that we do the same thing as we did with the history service. We said that, okay, the history service was getting updated by the key value store, and the key value store can now update the translation service also. Unfortunately, the translation service turns out to be slow because you have like 20 languages, you have to translate it. It doesn't happen immediately, which means if you are directly calling the translation service, the key value store might become slow. So what do? You say that, okay, we have heard of this Kafka thing, this data bus, which has already helped a lot of us. So why don't we use that? So what we could do here is that the key value store could say, okay, whenever I get something new, I will publish it, and the history and the translation service can just consume from this topic and then update the search index, and then the whole picture is complete, right? This is the power of microservices. Independent services coming together to build emergent behavior, doing one piece of the puzzle, doing one thing very, very well. However, there comes a feature sometimes that doesn't fit into any one of them, right? Think about an expiring key in this case. A key value store, now we want to do expiring keys. Where do we put it? We have to definitely put it in the primary key value store So we have to implement a timer which says that, okay, an expiring key after 10 minutes needs to be deleted. So we build an implement timer in the key value store. But we also have to send this across because there are these downstream services like the history service and the translation service that also need to delete it, right? Because the product works as a whole, all of these parts have to also delete their keys if it's an expiring key. So we send control messages, and the history and the translation service now needs to understand these messages. So the history service was very independent of its own. It was doing its own thing. It was decoupled. But now we have kind of brought data coupling into the picture because these control messages are very specific to the key value store. So suppose the history service was serving history for, I don't know, another part of the business. Now it becomes tied to the key value store. So this is not a very good way to go because then everything is like, again, getting coupled. Not temporarily, but as a data coupling. Another option would be to say, okay, we have these independent services. Why don't we implement the timers there? So everybody implements timers. It is still no longer data coupled, but then we have 3 timer implementations. And the re-implementation is itself not the problem. The problem is that what if one timer goes off, the other doesn't, right? It's inconsistent behavior to the user. It could happen. The fundamental problem here is that these fragmented pieces that we have, they were designed with the good intentions, but once fragmented, they do not compose well to form newer features or newer use cases. So this expiring key doesn't fit well into any one of those microservices. So that's why we are struggling to put it somewhere else. An option would be to say, hey, why don't you build another service, a reminder service, so to speak. And that would tell everyone, okay, it's time for you to delete it. So we don't have any of those coupling issues. We don't have re-implementations. That could work, but then how many such services do you want? Like services that orchestrate other microservices, it just keeps becoming bigger and bigger, and the domain gets lost in this because this is just one. What if you had more than this, which had to orchestrate other microservices? But let's focus a bit on the right. We had this data bus. We agreed as a community that it's good to have this data bus, a Kafka bus, for example, here. But what if it wasn't just a data bus? What if it was a control bus, so to speak? Just like in CPU architecture, you have this control bus also. If we say that, okay, instead of a Kafka pipeline which just sends data across immediately, what if we had something like a black box or a platform thing which could do the timing or the timer implementation for us? So that we, as the owners of the domain or the product, don't have to build this ourselves. We don't have to build, let's say, the reminder service today and then tomorrow the forget me service. This kind of couples on, the complexity just goes over and over. A central piece, which we agreed, Kafka was a good one, why don't we add more stuff to it so that we can remain more domain focused? And this control bus, not just timers, what if it could do, if I were to make wishes, I would wish for all of these things like retries, fork and join, parallel execution, conditional executions. Basically, it becomes a way to compose our domain-driven microservices in a lot more cohesive manner. So that's really good, and I think it would go a long way because instead of these services which I said in the beginning were like pieces of a puzzle, the fundamental problem with these puzzles is that they fit in only one way. This piece only goes in with the other piece. Instead, with a central piece that could help us compose things better, we would have something like a Lego brick. Our services would become more composable, would do a lot of things, and we can build anything with it. That's the ultimate goal. Now let's take a pause on the system. Let's look at the other problem that I started with, which is fragmented systems are harder to understand. So let's take an example. Suppose I'm part of a team that owns a microservice. Of course, the microservice may call some other microservices, the local dependencies, and we also would know who calls us, right? So we know who calls us, and we know who we are calling. But there is a whole lot of other microservices in an organization that we may not be aware of. So what we get to deal with day to day is a tiny slice of the larger picture. Our worldview revolves around our immediate neighbors. And therefore, when you bring the user into the picture, it's much harder to know what the user is doing as a whole. Because the user is interacting with the product as a whole and not as the services that we build. So to the user, it looks like this one giant thing, and that's what we want to do. But underneath all of that is the fragmentation. And because we want to build for the user, local context is not enough. So we have to really understand overall what we are trying to do. So what do we do when a new feature request comes in or we want to build for the user, just like the expiring key? We say, okay, let's try to discover the scope. Let's try to understand how it works today, because we are only aware of this tiny slice. And that's what I mean by the untangling of the spaghetti. So what we do, we have a new feature, we have a new thing that we want to give to the users. So we trace the call through the services, goes down to our local context, leaves our local context, goes down even further, and then we have finally the end-to-end picture. Each of these pieces are doing something. Each of these microservices exist for a reason. The user came to us as a whole, but each of these is doing something. So whenever we say that we want to give new features to the user, that feature can be spanned across any of them. That's why we need to have this discovery. And this discovery is costly. This is not something that we do for free. Sometimes we have to actually go and talk to the teams, hey, how does this thing work? I'm trying to build a service, how can you help me out? That kind of thing. And we do this repeatedly because the system changes from time to time. So what we need is a better mental model, a mental model that more mimics how our users look at the system. And we can do that. And we can do that because so far we have been looking at the services level. We can look at it from the product level. What does the user really try to do? And that's what brings me to the organizational cohesion, because it's not just the systems that exist, right? We work as a whole, and technical, non-technical, everyone comes together to build something for the user. So the tech teams, they understand the local context. That's us, that's me. We understand microservices, requests, response, data flow, dependencies, protocols, whatnot. That's already a lot of things to keep in mind. And that's why we tried to break it down in the first place. But overall, the non-tech teams, the product teams, the business teams, and the rest of the organization really wants to talk about the global context. And that's really important because when we build for the user, we build for the whole product, right? What needs to change across the product? What does the user really need? And that requires global context. So we need to make these two parts of the system, not the system, parts of the organization come together. And we can do that. We can do that with a diagram, because if you look at a system design interview, you start with a diagram. If you look at a new initiative, more often than not, you start with a whiteboard. So the diagram is a very versatile tool in conveying very complex ideas, right? And we use that. Just look at the number of products that build diagrams are. From Plant.uml, open source Plant.uml to GraphViz and whatnot, they are all there because we have understood that diagrams play a role in our understanding. But most diagrams are historical reflections. They don't get updated. We build a diagram, the perfect diagram, tomorrow they change something in one service and this diagram is outdated. Now you have a pile of outdated diagrams that just confuse you even. Instead of helping you, it confuses you. But what if we could have diagram-driven systems? Systems that were driven by this thing that we all understand, tech and non-tech. So let's start with something. We said that on the system level, it's hard to change microservices because they don't compose in many different ways. We also said that a fragmented system is hard to understand. Can we solve this with diagrams? So let's now look at it from a very high level picture. What did we want to do when we said that we want to build a key value store? We said we want to set a key. After setting the key, we want to do a few other things. Update the history. We want historical view of the data. We want to add translations because we want to search in multiple languages. And then we said that we'll take a decision. What is that decision? Is it an expiring key or not? Because if it is not an expiring key, this is it. If it is an expiring key, wait for a while, and then do some other things, which is to delete the key, delete the history, and delete the translations. I was able to explain this in 1 minute, and it was fairly easy to explain, though there are microservices underneath. If I just showed you the API spec, it would be much harder to explain what is happening. And that is the real impact of this. We did not talk about microservices, we did not talk about APIs, we purely talked about the semantic nature of what we are trying to do. This is the mental model that can unify all of us, the tech and the non-tech. And it hides away the underlying fragmentation. The underlying fragmentation is important. The microservices are important. They do domain-driven things, and they are there for a reason. They will stay, I think. But if you go back to that system-level diagram, and we look at that Kafka piece, and replace it with something else, and we take that diagram that we said that we all understand, put it inside this control bus that orchestrates the microservices, then it becomes a real powerful construct. Because for the systems, it acts as a control bus, but for the organization, it acts as a semantic layer to understand what we really want to do as a product. So the diagram becomes the declarative specification. No longer a historical reflection of what we think the system looks like, but really the specification of how things compose with each other. And that becomes the orchestration layer between domain-driven microservices, ultimately like solving the problem of fragmentation as a glue. So here is our piece of the control bus. We said that we had domain-driven microservices, and then there was an API. So when the API kicks off, we literally look at the diagram to take a decision on what should happen. So we said that we want to set a key. Inside this diagram, there are some properties, and that says, okay, now for this operation, you need to go to the key value store. Once that is done, it says, okay, do some things in parallel. So the system, the control bus, or the orchestration layer, as you might want to call it, it calls the downstream history service and translation service in parallel. Then it says, okay, I need to take a decision. Is this an expiring key or not? If it is, then I wait. Let's say I wait for 10 minutes, and this waiting logic is not in the domain services. They are there in the control layer. After the waiting period ends, we do a few things in parallel to clean up the data across the microservice. So this diagram that was universally understood, I explained it in 1 minute, was powered by the dedicated microservices underneath. And that's why this brings a lot of things together. The organizational cohesion really rests on these two parts of the system working together. And I think this is really powerful. So what is BPMN? BPMN stands for Business Process Modeling Notation. And this is the diagram that I was referring to. It is an open standard. It is there on bpmn.org. Ultimately, it compiles down to XML. So anybody who wants to implement this standard could build their own framework also. But there are existing solutions. Flowable and Camunda, these are orchestration engines that take the diagram as the input, not some API specification, not some programming language, but the diagram. And that is the key element here. So all of that to say, doing this allows us to focus on the essential complexity. Because when we started out with this key value store, we said that we want to support historical key values. We want to search for translations. We want to have expiring keys. But we spent a lot of time doing repeated implementations, overuse of one technology, prolonged discovery, basically not doing the things that we really wanted to do. We spent a lot of time just doing other things. And a system like this could bring us together to allow us to spend more time on the essential complexity of a domain. That is the key value store. And the rest of it, both the business and the system side of it, could be solved by having a language and a system that brings it all together. So fundamentally, the question is, we have fragmentation, and we fragmented our system knowingly. Microservices was not something that happened. It happened for a reason. But it also made our systems fragmented. But there is a cost to it, right? Because microservices gave us a lot of benefits, but it also introduced a few other things as well. And fragmented systems are accidentally complex. They didn't become complex because of any particular reason, but because of the fragmentation of it, like the fragmentation itself, it is accidentally complex. And by that I mean it's difficult to change and it's harder to understand. BPMN diagrams can act as a glue because it allows us to see the product as a whole, what the user wants to do, the mental model that we wanted to actually have for the user from the user's perspective. And it also makes our systems adaptable to change because now we have different ways of putting things together, be it parallel execution or timers or callbacks or alternative executions, all of that through the diagram. I think it brings humans and systems together to form organizational cohesion. And that is important. And that's why I think we should discuss about BPMN diagrams to untangle the API spaghetti. Thank you.
Thank you so much, Mourjo. That was a fantastic talk. I'm an architect and I do this on a daily basis. And what you said resonated with me so much, so thank you.